Okay, guys, so a lot of people without power, and we're just sort of having people slowly trickle in here. I'm gonna give it a minute, and then I've got a backup plan. So if this ends up being like 10 people, I'm gonna switch to the backup plan. So just give me a minute, and I'm gonna see how many people are able to join. I know I have no power either at my house, so we're all in this together. Let's see how it goes here. Just got more and more people adding every second. All right, we're getting more in. For people just joining, we're just gonna give it a second. I've got an unstable internet connection. I don't even know if you hear me, but hopefully. You guys, can you chat at me if you don't hear me, please?
We hear you, Miss Brooks.
All right.
I can at least.
All right, awesome. All right, I'm just doing roll. I'm gonna give it a minute for everybody to join because we got power issues. Christian, can you unmute and tell me which Christian you are? So I keep telling you guys to add your last name.
Peterson.
Whit? Peterson?
Peterson.
Thank you.
Yep.
Can you add your last name? I always get messed up with that. All right, we're getting more, so hold on. Here we go. For people that just joined, if you could give me a second, I'm seeing how many of us joined because I've got a backup plan. So I want to figure out how many we have actually today. Okay, so all right, so I'd say I have like half of you. I'm gonna go ahead and do the class with you guys, and then the people that are watching this, like probably on the weekend, whenever you have internet connection. Hold on one second. Okay, so I've got a good chunk of you now, so I'm gonna go ahead and do the lesson on Pear Deck with you guys. For those of you who are watching this later because you have no power right now and you can't connect, I'm gonna have you guys just answer the questions in a Google Doc and submit them. Oh, we're getting you more in. And this is something you guys always will do, like if you're absent or you can't log in, just go ahead and watch the YouTube playlist. Let me show you where that is. If you go to my front stream, then I record, like this is being recorded. All of our lectures are always recorded. And if you go down to the YouTube playlist right here and you click on it, I'm not gonna do it because it's gonna slow me way down on my hotspot. If you click on that, every day at the end of the day, I post all of these recorded Zooms, right? So if you're absent and you're not able to do your power, then you're just gonna click on that. You're gonna watch what you missed. And I prefer you to watch it instead of just doing the Pear Deck by yourself alone, because I want you to hear as much of the lecture as you possibly can. So that's what I want you guys to do, is just watch the lecture, answer the questions on a Google Doc, and then submit it right here. In your classwork, so right here where it says daily classwork of 10 points, that's where I always give you your 10 points. You can just add your Google Doc with your answers to the Pear Deck right here. That being said, I have a backup plan for today. If for some reason I lose all of you in my Zoom, I have a self-paced Pear Deck lesson right above it that you can click on, but then you're on your own trying to figure out what everything means and then watching the videos by yourself and answering the questions, and it's not as easy. So I'm gonna try not to use that. That's only a backup plan, okay? So let's go ahead and go through the agenda really quick. I know I still owe you guys a chance for the quizzes, extra credit, the second one. I'm gonna do that Monday because I feel like I wanna let everybody have a chance to try to get that, okay? All right, so your Flipgrid was due, and I know that a lot of you guys lost power, like I lost power as well around 6:37 last night. So just turn it in late, and also just send me an email so I don't mark you absent. So please just submit it when you can. I just showed you if we have problems today, we're going to switch to student-paced version of the Pear Deck. And we're going to continue on where we left off on our lecture. And then last is I'm going to have you guys sign in to a Chem 101 program. The instructions are all on my slides today and in the student-paced version of your Pear Deck. That won't be due until next Friday, but I'm just going to sort of try to like roll out like getting you used to the program. And so I'm going to try to give that a go today. All right, so let's go ahead and go to the Pear Deck. So let me start that. Oh, got one more joining us today. Here, hold on one second. So I'm going to start the lesson. All right, so here we go. Here we go. It's a little slow. Okay, so this will be your 10 points of class participation for the day. As I said, I'm trying to do the second quiz with you guys Monday because it's not fair for the people that didn't have power today to lose out the extra credit opportunity. Things are slow today because I don't have power. I'm on a generator, so bear with us here. Come on. And if this doesn't work, we might have to move to the student paced. Come on. All right, here we go. All right, so it looks like we are going to joinpd.com and then put the code JLTPQI. So I'll put that in the chat. So joinpd.com and then put in the code JLTPQI. JLTPQI. I'm going to close that because it'll pop up. Looks like I have 6 of you in. 11 of you, good. I'll put that Pear Deck thing up again. We're at 12, so I have 17 of you, just waiting on 5 of you guys. I know the internet is not stable, so everybody's struggling. 13. 15, almost there. I'm just waiting on a couple more. So that's an L, J, L, T, P, Q, I. All right, I'm gonna go ahead and get started. The code is up here, guys, on the top right-hand corner, JLTPQI, and also it is in our chat. So let's go ahead and get started. We left off, this is the very last section of Unit 0, and once we're done with this, we're gonna do a lab. Well, I do the lab. You guys like watch and answer questions and fill out your data table. But then after that, you guys have a test. So we actually have almost come to the ending, and I will do that last quizzes for review on Monday so everybody has a chance to see that. Natalie, the code for the Pear Deck is right up here. It's JLTPQI. Go ahead and go to joinpd.com and enter that code. I'll type it one more time for you. Joinpd.com in the chat. Code is JLTPQI. All right, so let's go ahead and move on here. All right, so I had this last time, and I think I already went over this with you guys, but you know, especially right now, one thing I want to say is I heard that when the fire happened, a lot of our students went out, or ex-students, former students, and some current students went out and helped to put that fire out. So, you know, you are always in charge of your own life, and that's really important. Nobody's gonna save you. I know a lot of people think they're just waiting for someone else to come in and just save your life. That's not how life works. So be in charge of your own life. Every day you wake up is a new day, and you wanna wake up to be the person you always dreamed you wanna be. So keep that in mind every day, especially right now with all these things going on. The Flipgrid was due last night, but I know you have power steps, so don't worry about it. If you did not get that done, just do it whenever you can. But email me and say, hey, Brooks, I need an extension because I couldn't access the internet, so I don't mark you absent, okay? So I will be putting those attendance codes in probably around lunchtime today, and so make sure you tell me that. All right, that was the Flipgrid from yesterday. All right, where we left off was collecting data. The last chunk of this unit is labs, and so we want to know, how do we collect data and how do we do it correctly? We already went over this. These are some of the tools we use for our units in science, and you can see things that are familiar, like when you're driving your cars and you have your speed in miles per hour, and pressure and stuff like that. You guys can't hear me? Can you guys unmute? Andrea, you're saying that I'm cutting out. Can you unmute and say if you can still hear me? Yes, no, can you hear me?
I can't hear you. I don't know about anybody.
I can hear you, you're just kind of lag.
Okay.
Yeah, it cuts off.
I'm just slow, huh? Okay. All right, well, I'm just still gonna go through it as much as I can. If you completely can't hear me at all, then let me know. And I am recording this so that you'll be able to hear what I'm actually saying in the recording. So, and then I'll post it at the end of the day so that if you need to hear what I'm saying better, then that'll work. Okay, really quick. So this is just all of your units, right? Like these are things you've seen before in your life. They came to, this is a review. We talked about this already. The world came together as scientists and said, we can't have different languages. So this is what we use. We use the International System of Units because we don't want to have to deal with language conversions in science. So these are things you're familiar with. They're called the 7 SI base units. We have meter for length, mass is kilogram, time is seconds, ampere is amount of electric current, Kelvin is temperature, brightness is candela, and mole is the amount of chemical substance. Some of the units you may not see on there because they're actually derived. So these are the ways that we come up with things like speed, area, volume, and density. These are things that are length divided by time for your speed. You take those 7 SI base units and mathematically you can manipulate them to create new units, and that's what this is. So area is your length times length, volume is length times area, density is your mass divided by volume, and you guys have seen these before in your math and science classes. And we already talked about how volume is 3-dimensional. That's what the last derived slide was saying. So if I wanted to do a length, it would just be 1-dimensional. It'd be like, oh, meter, miles, kilometer, right? But if you have a 3-dimensional object, that means you have to do the length times the width times the height. And that's what you're seeing right here on this slide, is that volume is actually 3-dimensional, okay? So our units for volume are a liter is equal to a decimeter cubed, 1 milliliter is 1 centimeter cubed, and a milliliter is 1 liter. These are all different types of volumes that we have, okay? The reason we have the SI base unit system is because there are prefixes, which you've already probably used in your life, the metric system, right? Where you can put like kilometers or milliliters or centimeters. And so these prefixes are just a way of moving the decimal point around to have a bigger or smaller number for your SI base units. This is how we use the prefixes. So I'll just walk you through this slowly when we get there, okay? Just know that this is a unit conversion table that we can access and use, okay? All right, so now this is where I'm gonna try to show you a video and we're gonna see how it goes. All right, so I need you to be able to, in the lab, go and measure mass of either a solid or a liquid, okay? So I've recorded some videos on how to do that, and on Pear Deck for your 10 points, I'm gonna show you the video first, and then I want you to answer these 3 questions after I've shown you both videos, okay? So number 1, so pay attention because you're gonna have to type your answer on Pear Deck. Don't do it yet because we gotta watch the video first. But I'm gonna ask you, what does the 0 or the tare button do? Some of you might know the answer already, I know, but just wait. Number 2, what should you always put down first under any solid? And then number 3, what is the last digit of any mass on the scale called? Okay, now I'm gonna show you videos on this. If you're not here right now and you're watching this video because you didn't have power, you're gonna open a Google Doc and you're gonna type these 3 answers out and you're gonna submit them on the Google classwork, okay? So let's go ahead and watch those videos. Actually, don't want to stream them. All right, here are purple. Wrong one. I don't want to stream them, so I'm going to show you the video here.
Students, so now we want to figure out how to use the same scale.
Wrong one. Oh, here it is.
Okay, students, so here's a digital scale, and this is going to be different from what you used in middle school, which was the...
Can you guys hear and see that? Just let me know first before I spend hours.
Yeah, I can.
Okay, cool. All right, so we're gonna watch this and then we're gonna answer the questions. So pay attention to what I'm saying right now.
Triple beam balance. Well, and this is going to be different from what you used in middle school, which was the triple beam balance. Now, the first thing, no joke, I find a lot of people mess up on is that there's a lid. See that clear thing? You have to lift it up. A lot of times students do this and they're like, why is it not working? The answer is you have to lift the lid up. That's a protective layer. Next thing is that there's an on button, so you're going to turn that on. Wait for it to light up, and sometimes it goes through just different little things in here. There we go. So now it's saying 0.00 grams. Okay, so when I am going to weigh something, I don't want to put it directly onto the scale. Now, as you can see, there's little things like, I left that on purpose so you could see that. There's just little damage that is caused when you put the chemicals directly onto the scale, so we don't want to do that. So what we do is we use something called weigh paper. Now, I'm at home, so I'm just using a paper towel. It doesn't really matter, honestly. It's just a protective layer so you don't damage the scale. So I'm going to put the paper towel and see how sensitive the scale is. It already weighs the weight of that paper towel. Or not weight, weight is different from mass. It's the mass of your paper towel. And so we don't want that because I'm going to show you how to record the mass of solids versus liquids on this scale. So I need to get rid of that solid paper towel mass. I don't want it. So what do? We have a feature in science where we have something called a zero button, or sometimes it's written as a tare button, T-A-R-E. You're going to push that. It's gonna just zero out the weight of that paper towel. And okay, that was the first question. So everybody on your Pear Deck for your 10 points right now can be putting the zero or tare button does what? What did I just show you it does? So you can say number one, like if you're watching this recorded and you're doing this later and you're turning it in for your credit because you aren't here, you just open up a Google Doc and go ahead and say number one, the zero or tare button does what? What is the point of the zero or tare button? All right, let me see who's answering here. So I'm waiting on Jose, Yuli, Sergio, Hugo, Beckham, Augie, and David. So what does the zero or tare button do? So I just showed that in the video. What does it do? Let me go ahead and replay it while some of you guys are typing. So right here. Not weight, weight is different from mass. It's the mass of your paper towel. And so we don't want that because I'm going to show you how to record the mass of solids versus liquids on this scale. So I need to get rid of that solid paper towel mass. I don't want it. So what do? We have a feature in science where we have something called a zero button, or sometimes it's written as a tare button, T-A-R-E. You're going to push that. It's gonna just zero out the weight of that paper towel. And now I'm just doing, okay, so what does the zero or the tare button do? I can't even talk this morning. This whole power outage has got me all crazy. Okay, so everybody's starting to respond for your 10 points. Good. David, I don't have a response for you. If you want your 10 points, I need you to start typing on the screen. The zero or tare button does what? And I'm gonna go ahead and pick some of your guys' answers and show it on the screen right now. I'm picking some good answers here. All right, so
I'm going to show some of these responses. Let me minimize this. And where are we at? All right, here we go. So these are correct answers. So I picked some of your guys to show. The 0 or tear button, when you guys are weighing something on a scale, for the rest of your life, trust me, even when you cook and chefs and stuff use some of this sometimes, you have to weigh just maybe the food that you're trying to weigh or just the chemicals you're trying to weigh, but you put things like paper towels down so that it doesn't damage the scale, or maybe you put down a beaker that's empty so it doesn't damage the scale, whatever it is. You don't want the weight of that paper towel or of the beaker. So the 0 or tear button is used for resetting the weight. For example, in the video, the mass of the paper towel is not needed since it was just for protective purposes. Perfection. If 0 out the paper towel mass before weighing the liquids and solids, perfect. The button just makes the weight of the paper towel go away. It just brings the mass to 0. Perfect. All of those are exactly what I want. Okay, so the next question we're focusing on is number 2. What should you always put down first under any solid? Okay, we actually already did that. What did I put down under the, on top of, let me open up the video for you guys one more time. What is that? What did I call that paper towel? So number 2, what do we always put down before we put any chemicals? I don't know if any of you guys remember the name of it. Let me actually go back here and I'll bring it up to the exact part. There's actually a name. I'll take a couple of answers, but the name is, here we go.
We don't want to do that. So what we do is we use something called weigh paper.
Did you hear that? What was that called? That's what you're typing right now. Number 2, everyone, what was the name of that paper towel? Here we go.
So what we do is we use something called weigh paper. Now, I'm at home, so I'm just using.
So everyone should be typing that. The second thing, this is really, really important when you guys are using scales. You don't want to damage it. So we use something called weigh paper. Awesome. You guys are getting that. So type for your answers. The 0 button, the 0 or the tear button is used to 0 out whatever you don't want to weigh. And then the paper itself, the protective barrier, is called weigh paper. It's just, you can use anything. You can use a piece of paper towel. You can use like wax paper. You can use whatever. It doesn't matter. It's called weigh paper. Awesome. So it looks like, oh, it's not wave paper. It's weigh, W-E-I-G-H, just for some of you guys. Well, awesome. It looks like all of you guys are getting that. I'll go ahead and show a couple responses. So really quick. For those of you guys, I want to make sure you know the right spelling here. So weigh paper, this one right here, that's how you spell it. Weigh paper is fine. Okay. All right, so third question we have to do is, what is the last digit of any mass on the scale called? So let's go ahead and finish this up. I think we're right here. Hold on. We're right here on the 0. Okay, here we go.
Now I'm just doing something basic like sand. So I am going to take the sand and just put it, scoop it out and put it straight on the scale. So let's say this is a chemical. There we go. And it's very basic. See how easy digital scales are? That's why we use them. I do want to point out that sometimes these scales read more digits. The more digits that it reads past the decimal point, the more expensive the scale is, because that's how accurate it is at weighing.
Okay, so you guys are saying you can't hear? Let me,
Yeah, it was cutting off a little bit.
okay, let me, I'll redo it. Let me know in the chat if you hear it now.
So let's say this is a chemical. There we go. And it's very basic. See how easy digital scales are? That's why we use them. I do want to point out that sometimes these scales read more digits. The more digits that it reads past the decimal point, the more expensive the scale is, because that's how accurate it is at weighing or actually, you know, measuring the mass. And so I don't want to say weighing, but measuring the mass. So the other thing I wanted you to notice is that sometimes these things fluctuate, okay? It goes up and down a little bit, and that's just, sometimes it can be air movements. What I always say to my students is record the number that it stays on the longest. And the other thing is just maybe your scale needs to be calibrated or it's old. This is just old and cheap, so it just keeps changing a little bit. So that's actually an important point. So I'm gonna put 1.47. So the weight, the mass of the sand is 1.47 grams. Okay, now, this is a good time to bring this up. We just saw that this last digit kept changing. The last digit is known by science to be like not valid, you know, it changes. We saw it change. So this is what we call the uncertain digit. So the last digit is always the uncertain digit, okay? And so you have to record the last digit, even if it keeps going up and down. And that's actually a good point that most students are saying, hey, well, what do I write down? The last digit's going up and down. Am I supposed to write that? Yes, because all scientists know that the last digit is uncertain, okay? And this comes up when you talk about in higher level chemistry, what we call significant figures, because that last digit is unknown. It's significant, and we say it's significant because the scale was capable of measuring all of those digits, but the last one is just uncertain, okay? So I would say that that's 147 grams, and so that's how you weigh your solids on the scale. Okay, students, so
all right, so you can see,
this is going to be your solids on the scale.
All right, so there you go. Everyone should be able to type now what the last digit is called. This is actually really important in science. When you go into college, you're going to do a lot of labs. It doesn't matter what piece of equipment you're using. There's always going to be uncertainty in an estimation because nothing's perfect, right? And so the last digit on a scale will go up and down. When you're measuring in beakers and in lines with liquid, you're also going to estimate that last digit with your eye as well. So all scientists know that the last digit is called the uncertain digit. So I'm going to pick someone's answer here. Everybody should be typing this for your points. The last digit is called what? Let me see it, guys. So I need you guys to change your answer and put, what is the last digit? Okay, Jeanette, significant figures is something for higher level chemistry. I want you to say what the last digit is called. A lot of good answers here. I'm going to just show 3 responses right now. And let's look at it. The answer to this is the last digit of any mass is called the uncertain digit. It's not valid and unknown. It's sort of like fluctuating, so we're not certain. It zeroes out the paper to, oh wait, sorry. I didn't mean to pick that one. Let's take that one off the screen. Here we go. The last digit is called the uncertain digit. The last digit is called the uncertain digit. You guys get it? The last digit is called the uncertain digit. No matter what piece of equipment in science you use, the last digit is always uncertain. All right, I think you guys got that now. So we've answered all three of these. The only thing now I want to show you is how we would do the same thing, and you have the same three principles of using a scale, but now applied to liquid. So let's go ahead and look at this, how to use a digital scale for a liquid. So we just did the solid for the mass of the solid. How do we do the same thing but in a liquid? All right, let me minimize that and pick it up.
So now we want to figure out how to use the same scale but with liquids. So what we just did was solids. Sand is a solid, so we just finished the mass of the solid. Now, what if we have a liquid? Well, liquid, we can't just get out a wave paper, put it on, and then put the liquid on there. You know, it doesn't work. So here's where we have to do a different method. There's two things that we can do here. We can just put the beaker on, and then again, I'm gonna show you two methods here. Put the beaker on, hit the 0 button. Now it doesn't weigh anything, just like last time. And then put the liquid in. Oops, I got some on scale. Maybe I want to know how much that liquid mass is in there. I'm just going to write that down. So that's 14.07 grams. So the mass of the liquid water, that's all it was 14.06 grams. And again, this is the uncertain digit, right? So the last number you always write, even if it goes up and down, maybe it changed a little bit, write down the one that stayed on the most. It's still stuck on 14.06, so that's what it is, okay? All right, so now the other thing is what happens if your tare button doesn't work or you're using a scale that doesn't have a 0 or a tare button? How do I measure the mass of the liquid? Well, for this situation, we're just gonna measure the mass of the beaker. So you're gonna write that down. It's gonna have to do some basic math here. So that's 49.70 grams is the mass of you always want to be detailed in your lab notebook, mass of the empty beaker. Okay, so that's the empty beaker. Now we're going to add some liquid and watch the mass go up, right?
Wow.
And then I need to know, well, how much is the mass of that liquid, not the mass, because this right here is the mass of the beaker plus the liquid inside of it, okay? So let's go ahead and write that down. So I'm gonna put it up here on top so I can do the easy subtraction. 65.67 grams is my mass of beaker plus the liquid water, okay? So if my question is, how many grams of just water, what do I have to do? This is just basic subtraction from when you guys were little, you know, elementary school. So you're just going to subtract 7, and 16 minus 7 is 9. So that becomes 5 and 1. So I'm just doing my basic math here. 65.67 grams minus my 49.70 grams means that the 15.97 grams is the liquid water that I just added. And so sometimes it's a beaker that you're trying to, you know, deal with. Sometimes it's actual other objects that you're trying to neglect the mass of that. But, you know, just using those, think about it. Think about what has mass and then how it's changing when you're doing your subtractions. So this should help you guys figure out the different ways that we use the digital scales. Okay? All right.
Okay, so really quick, I just want you guys to understand that there's two ways to measure liquids, because liquids aren't like solids. You can't just put them on top of a piece of paper. You always have to put them in a beaker or something. So if you guys are, sorry guys, the school's calling me. If you guys are trying to measure the mass of the liquid and you can actually use a functioning 0 tare button, then go ahead and zero out the weight of the empty beaker.
Lagging again.
What? Andrea, did you have a question? You just were talking. I don't know if it was. Hello? All right, I don't know. You guys can chat at me if, oh, you guys are lagging. Okay, hold on. Can you guys hear me now? Can you guys hear me yet? Okay. All right, so sorry about that. When you're doing masses of liquids, you have two ways to deal with it. And that's what I was trying to show you on that video is first, obviously, tare button is always the easiest, right? You just put the empty beaker, hit the tare button, then add the liquid, done. But sometimes in science, you don't have that option. Like for example, maybe you already have a set amount of liquid in the beaker, and so it's beaker plus liquid. So you're gonna have to write down the math like I just showed you. You're gonna have to write down the mass of the beaker plus the liquid, then add the other third liquid or second liquid that you're trying to add, and you're gonna have to do some subtraction like I just showed you, okay? So think about the math. Every time you do measurements and lab data, it's really important that you think about the math, okay? So that's what I was trying to show you there. This is actually a real basic concept, but guys, when you get to college, if you can't do these basic things, your whole lab blows up, no matter which lab you're doing. You could be doing biology, you could be doing chemistry, you could be doing physics. If you don't know how to operate these little basic things, it really blows up everything else. So make sure that you're thinking about it logically every time, okay? All right, so these are some other ways that we can measure volumes. So we have, let me just go over some basic names here. This is actually our burette and a pipette, which the names are actually on the bottom for you as well. A graduated cylinder, something you commonly use or probably have already used in your life. And then there is a volumetric flask. So the difference in these four things for measuring volume is this one over here on the left, the burette, is usually used to drip some chemicals into something. So you can see down here, there's a knob that you twist, and it actually starts up at top and you measure the volume as it goes down. The other one, a pipette, is something that's very specifically calculated and it only measures one specific volume. So you can see there's just, this one is 25 mils and that is it. And so you would have to go get the matching volume pipette in order to get the correct volume. So they have them in all different sizes. They got 5 mils, 1 mils, 0.1 mils, 0.0001 mils, 100 mils. But for those, you have to get the right matching glassware for that. Graduated cylinders you've already used before, and I'm actually going to show you how to use those again because I think a lot of you guys still use them wrong and we got to fix that. And then the volumetric flasks are typically used for making bigger batches of things like 1 liters, and they're similar to the pipette. You have to get the matching glassware. So this is a 1 liter volumetric flask, but there are other things like 500 milliliter ones you could grab or 2 liter ones you could grab, all that. Okay, so we're gonna go ahead and move on. The graduated cylinder is the common one we use in high school science. Now, people do it wrong, so I have made a video to make sure you do it correctly. If you get to college and you read a graduated cylinder incorrectly, people are gonna look at you like, what is wrong with you? Like this is basic. So it's really important that you do this right. So key things that I put right here, I want you to fill out these in your Pear Deck on your typing in your answer for your credit. If you're watching this on YouTube later, you're in your Google Doc, you're gonna type out the answers to this right here. So you guys can go ahead and type this right now. Measure volume by looking at the fill in the blank. I'm gonna have you type that part. You can put a question mark for now. Measure volume by looking at the question mark of the question mark at the question mark. I know it sounds weird now, but trust me, I'll get to that, okay? So if you guys could all type that part in right now, we'll fill out the question mark parts. Measure volume by looking at the question mark of the question mark at the question mark. And then I will have you guys fill that part out. Once I see everybody has at least typed that part, then I'm gonna go ahead and start the video. Okay, so I'm waiting on, let's see, who am I waiting on still? Jose Martinez, Jeanette Arroyo, Jocelyn, Isaac, Hugo, Beckham, Augie, Juan. Can you type this, what's in this box, type it and put question marks, and then we're gonna fill in the question mark as we watch the video. All right, so let's see, I'm still waiting on Hugo for your 10 points. Antonio, Jose, and Jocelyn. If you guys could just type that out for me and then I'll start the video. So Jose Martinez and Juan Martinez or Antonio Martinez. Can you guys type that? All right, thank you. So just Jose Martinez, can you type that? There you go. All right, so we're getting that. All I need you to do is type this box. Measure volume by looking at the question mark of the question mark at the question mark. And we're gonna fill out the question marks now. So measure volume by looking at the question mark of the question mark at the question mark. And maybe some of you guys already know this. If you do, kudos to you. This is a very common, basic way of measuring volume in a graduated cylinder, but a lot of people don't know how to do it properly. So measure volume by looking, Jocelyn, I want you to type Jocelyn, Hugo, David, and Andrea. I want you guys to type measure volume by looking at the question mark of the question mark at the question mark. Trust me, you're gonna fill that out and it will make more sense soon. All right, there we go. Measure volume by looking at the question mark of the question mark at the question mark. Perfect. Okay, I'm getting you guys to type that. Except Hugo, where are you at? Are you on? There we go. Thank you, Hugo. Measure volume by looking at the question mark of the question mark at the question mark. Thanks, Jocelyn. You got that. Perfect. Jose Martinez, I want you to put measure volume by looking at the question mark of the question mark at the question mark. And we're going to fill that in right now. This is a huge sentence, believe it or not, in science, like all of science. If you don't know how to measure volume properly in a graduated cylinder with this one sentence that's really famous in science, people look at you weird in college. You're like, wait, what? You don't know how to measure the graduated cylinder? Okay, so here we go. Most of you guys have that. Measure volume by looking at the question mark of the question mark at the question mark. Now watch the video and see if you can hear that sentence, but filling in the blank, all right?
All right, here are purple liquids inside of these two different types of equipment we have in chemistry. The one on the left is just a plain beaker, and the one on the right is called a graduated cylinder. And so, as you can see, if I were to say, hey, what's the volume inside of this beaker, it'd be really difficult for you to give me an accurate reading because the glassware is not very precise. Remember how I talked about the more digits you have, the more precise it is with the scale? Well, look at this. There's 2 digits and it's a 6 and 0 would be 60. So you know it's definitely 60 milliliters, but then what? Like, okay, I don't know what else to do because my estimation would be way off. I mean, this could be 62 milliliters, it could be 65. That's an inaccuracy precision of, you know, between 2 to 3 milliliters or more. That's a bad way to measure liquids. So we try to go with the most precise glassware possible when measuring liquids. So we don't want to use just a regular old small beaker like this because it...
All right, it's lagging.
Right, so I think you should be starting.
We start from where? Like right here? All the way?
Yes, ma'am.
All the way, okay.
Like 15, 20 seconds.
Okay, let me go back to...
Yeah.
All right, here we go. Sorry.
As you can see, if I were to say, hey, what's the volume inside of this beaker, it'd be really difficult for you to give me an accurate reading because the glassware is not very precise. Remember how I talked about the more digits you have, the more precise it is with the scale? Well, look at this. There's 2 digits and it's a 6 and 0 would be 60. So
all right, I'm gonna pause for a second, guys. Still lagging, huh? Okay, hold on. I did just get a message popping up saying that it's unstable, so hold on. Just give me a second. If we could just get through this, then we'll be good. So, all right, can you guys hear me pretty well now when I'm talking? Just give me a yes or no in chat. Is it like pretty?
Yeah.
Okay, cool. So we're gonna try this one more time. All right, here are purple liquids inside of these 2 different types of equipment we have in chemistry. The one on the left is just a plain beaker, and the one on the right is called a graduated cylinder. And so, as you can see, if I were to say, hey, what's the volume inside of this beaker, it'd be really difficult for you to give me an accurate reading because the glassware is not very precise. Remember how I talked about the more digits you have, the more precise it is with the scale? Well, look at this. There's 2 digits and it's a 6 and 0 would be 60. So you know it's definitely 60 milliliters, but then what? Like, okay, I don't know what else to do because my estimation would be way off. I mean, this could be 62 milliliters, it could be 65. That's an inaccuracy precision of, you know, between 2 to 3 milliliters or more. That's a bad way to measure liquids. So we try to go with the most precise glassware possible when measuring liquids. So we don't want to use just a regular old small beaker like this because it's not measured accurately with the numbers. When we go here to the graduated cylinder, and hopefully you can see these okay, they have a lot more lines. Lines are known accurate digits, okay? Less uncertainty. So when we look at this, you can see that there's a lot more lines. I'm sorry, this graduated cylinder is sort of faint. I didn't have another one available. But you can see that there's 1 milliliter measurements for every single thing. So there's 10 lines between each of these 50 to 60. So you can tell that that means there's 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. Okay, so now let's go ahead and figure out how to do the measurement. All right, so how am I gonna read these liquids inside of these graduated cylinders? All right, well, we have 3 steps. Number 1, you need to get eye level, all right? Why am I doing that? Well, if I look at this liquid from here, I'm just estimating, all right? You can tell that as soon as I get eye level, I can really see the bottom of that U-shaped meniscus I'm gonna talk about in a second a lot better. If I'm looking up, well then again, I'm guessing because I can't clearly see things. So that's why the rule for number 1 stands. Always get eye level. Then number 2, you want to read from the U-shaped bottom of the meniscus. Okay, what is that? Well, I've drawn it for you first so you can look for it. But the meniscus is the U shape that forms, and I drew it on the paper for you, and then I said on the red, read here. So you're gonna read from the bottom of that U shape, okay? So meniscus is the U shape that forms when liquids are inside of glass containers, and that happens because of the attraction between the water and the glass, okay? But anyways, second thing you wanna do is you wanna read from the bottom of the U shape. So again, let me try to situate this well. If I get there, you're gonna see that it has a little bit of your U shape that you can see right there. 3, read between the lines. So this is gonna be similar to, on the scale, the last digit that kept going up and down, and it was called the uncertain digit. For this one, we need to read between the lines because the last one is uncertain. There is no line to say this is what that value for volume is, so you're gonna have to guess. What you believe is the last digit may not be the same as what I believe, okay? So let's go ahead and start by looking at this one. All right, let me get in here. So I need to get eye level so that I can see it. And you can see that this is clearly already past 40. So we know there's definitely more than 40, but is there more than 50? I don't think it's even reaching 50, okay? And I'm actually gonna turn it a little bit so we can see those increments. So I would say that there's 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. And then you need to read between the lines. To me, that looks like 49.8 is my guess, but you might have said 49.9. And you see how that last digit is uncertain? That's the point. So I'm gonna write down here that this has a volume of 49.9 milliliters of water for the volume. And this is your uncertain digit, which you are reading between the lines in order to do. And that is how you read liquids. So students, if you guys are doing this at home, then what I want you to do right here is put into your Google Doc, fill in these blanks. So measure volume by looking at the bottom. That's this bottom of the U shape. So this is bottom of the U-shaped meniscus. So it's the bottom of the U-shaped meniscus at eye level. Okay, the answer is measure volumes by looking at the bottom of the U-shaped meniscus at eye level. And that's the answer. Submit your Google Doc. We're stopping here for your 10 points. All right. So have a good day, you guys, and I will see you on Monday or Tuesday.